All right, welcome to the Explainer. Today, we are going to build a real intuition for big data. And look, we're not just going to memorize a bunch of tool names. We're going to get to the heart of why this stuff even exists, what problems it was built to solve, and how modern systems actually tame this, well, this massive digital flood. Let's dive in.
So, it really all boils down to this one simple question. And this question, it kicked off a whole technological revolution. Why? Well, because the old ways of doing things, they just stopped working. The amount of information just got so unbelievably huge that it literally shattered the systems we used to rely on.
And here's the crazy part. Just think about it for a second. Data doesn't get made in these nice, neat little packages anymore. Nope, it's a constant, non-stop stream. I mean, every single second, you've got millions of social media posts, censored data pinging from all over the world, financial transactions flying by. It's like a giant fire hose of information that is always on.
Okay, so you have this endless flood of information, right? And it just completely overwhelmed the traditional systems we had. I mean, it pushed them to their absolute breaking point. They just weren't built for this new world. So let's dig into exactly why they failed so spectacularly.
I love this analogy. The old way of doing things, it was basically like having a single, super meticulous librarian in a small-town library. You know the type. This person could handle a predictable flow of books, everything neatly organized in a perfect little card catalog. And it worked. It worked great, as long as the town and its library didn't grow too much.
And at the heart of that old system was a single, really powerful server. Just one. That meant all the data and all the processing had to squeeze through this one machine. You can probably see the problem here, right? It created a huge bottleneck. Our poor librarian, no matter how amazing they were, could still only do one thing at a time.
This really gets to the core of the whole shift in thinking. The old way was what we call vertical scaling. Basically, when you needed more power, you just bought a bigger, beefier, and way more expensive machine. But you can only do that for so long before you hit a wall, both physically and financially. The new way? Horizontal scaling. Instead of one giant machine, you just add more and more smaller, cheaper machines to the pile. It's such a simple idea, but it's what forced the entire industry to move from that centralized model to a distributed one.
Okay, so to really get a handle on this new world, we need to talk about the three big challenges that define it. You've probably heard of these before. They're famously known as the 3 V's of big data.
First up, we've got volume. And yeah, this is the one everybody immediately thinks of. We are so far beyond spreadsheets that can fit on your laptop, we're talking about data on a truly astronomical scale. I mean, petabytes, exabytes, amounts that are honestly kind of hard to even wrap your head around. All right, next up is velocity, and this is all about speed. Remember that fire hose we mentioned? Data is just gushing in, and a lot of the time it has to be processed right now, instantly. Think about fraud detection on your credit card. You can't wait until tomorrow to find out someone's on a shopping spree, right? Or think about your GPS app. It has to reroute you around traffic in real time. The key is you need that info now.
And the last V is variety. Think back to our librarian. Their card catalog system worked so well because all the books were, well, they were books. But today, data comes in every possible shape and size you can imagine. It's not just these nice, neat tables anymore. Oh no, it is a messy, chaotic mix of everything. Photos, videos, weird JSON files, endless server logs, the whole shebang.
So, when you've got this totally new kind of data, defined by that massive volume, insane velocity, and crazy variety, you're going to need a completely new toolkit. It just makes sense, right? You wouldn't use a hammer to fix a software bug. You need tools that were purpose-built for this new distributed world.
And this brings us back to our librarian, but with a twist. Instead of just one totally overwhelmed librarian, what if you hired thousands of them? You could just break up that giant, impossible collection of books and give a tiny little stack to each person. By having them all work at the same time, in parallel, they could get the entire library cataloged in a tiny fraction of the time. That right there is the magic of distributed processing.
So this new toolkit really gives us two main ways to attack the problem. First, you've got batch processing. The easiest way to think about this is like doing your laundry. You let it all pile up during the week and then you wash it all in one big, efficient go. Then, on the flip side, you have stream processing. This is more like washing each dish the second you're finished eating. It's continuous, it's immediate, it happens as it happens.
So the big question is, how do all of these different pieces, the distributed storage, the parallel processing, these batch jobs and stream jobs, how do they all actually fit together? Well, they come together to form what we call a modern data pipeline.
And this 4-step journey, this is really where the magic happens. Think of it like a factory assembly line. This is where all that raw, messy, chaotic data gets turned into clean, valuable insights. You know, like when your favorite streaming service gives you a movie recommendation that feels like it read your mind. That's the end product. And it all starts with getting the data in, finding a place to store it, doing the heavy lifting to process it, and then finally being able to ask questions and get answers.
Now, each of these steps uses its own set of super specialized tools. For instance, for getting data in, that ingestion step, you might use something like Kafka, which acts like the front door. Then you need a place to put it all, so you'd use a distributed storage system like Amazon S3. For the actual processing, the number crunching, you'd use a powerful engine like Spark. And then finally, to ask questions of all that processed data, you'd have a query engine like Presto that lets data analysts get answers and get them fast.
So, if there's one thing to take away from all this, it's this. Big data isn't just some marketing buzzword that means a lot of data. Not at all. It's a fundamental, ground-up shift in how we approach computing, how we approach storage, and how we approach analysis itself.
And this quote just nails it perfectly. It highlights the two absolute pillars of this entire way of thinking. First, these systems are distributed by default. They are built from day one with the assumption they'll run on tons of different machines. And second, storage and processing are decoupled. The place you keep the data isn't tied to the place you do the work on it. And that separation, that decoupling, is the secret sauce. It's what lets you scale both your storage and your computing power almost infinitely, without one holding the other back.
And that right there is why this all matters. Getting this high-level, 30,000-foot view is absolutely crucial. It doesn't matter if you're a data engineer or an analyst, or maybe you're just prepping for a big system design interview. Truly understanding these core principles is like having a superpower in today's tech world.
So that really leaves us with one final and kind of provocative thought to chew on. We've gone and built these unbelievably powerful systems. I mean, systems that can make sense of the world's data at a scale that was pure science fiction not too long ago. The technology, it's here. It works. So the only real limit now is the boldness of the questions we're willing to ask.